Okay, by now you've hopefully written something down here for numbers 1 and 2. What we'll do now is kind of summarize. So what you should have noticed was that your x-intercepts, here's an x-intercept at +1 and at +3, but look, it says x minus 3, x minus 1. Here we got x plus 2, but our intercept is at -2, and x minus 1, and our intercept is at +1. So basically, it's the opposite of what we would see. So the x-intercept occurs at the opposite of what we see. So x plus 2, that means x equals -2 is the intercept. Now, when we write intercepts, we should always write them as an ordered pair, -2, 0. That's how we write them. This is not telling me that this right here, that's not an intercept. That's just what x would equal. This is an intercept. Okay. Now, the next part, what you should have noticed was that the vertex was exactly halfway between your intercepts. Okay, so here, halfway between 1 and 3 is 2. So the x value of your vertex was at 2. Up here, okay, -5 and -1, halfway between that, you can count, would be -3. Oh wait, that's the x-coordinate of your vertex. So -2 and 1, halfway between those two values would be -1/2. There we go. Halfway between -3 and +1, halfway is -1. So that would be the x-coordinate of your vertex, or axis of symmetry. So what do you notice about the x-coordinate of the vertex? I spelled vertex wrong, so we can fix that. And the x-intercepts, the vertex is halfway between the two x-intercepts. So the zero product property, we just have to touch base on this real quick. Basically, it's saying if I have two things, say x times y equals 0, this means x or y must be 0. Okay? Because think about it. If, for example, x was 3, so let's do 3 times, but y was 0, that equals 0. No matter what x would be, if y is 0, when we multiply, we get 0 as the answer. And we could also think about the other way. If x is 0 times, it doesn't matter what y is, -11. Because x is 0, the product, or the answer when we multiply, will be 0. So we can use that to find these x-intercepts. In order to find x-intercepts, we're going to set this thing equal to 0. So x minus 6 times x plus 7 equals 0. Alright, so we have two things being multiplied. We have x minus 6 and x plus 7. So one of those has to equal 0. So we're going to do it for both of them. So x minus 6 equals 0, and x plus 7 equals 0. So we add 6, so x equals 6, and subtract 7, x equals negative 7. So these are my two solutions, x equals 6, x equals negative 7, and remember to write it as intercepts. We're going to write 6 comma 0 and negative 7 comma 0. So I set each part of these, this thing is being multiplied by that thing, x minus 6 times x plus 7. So set each part equal to 0. Now B, x minus 6 squared is really x minus 6 times x minus 6. It's the same thing. Now, we only have to worry about one of these because these are the exact same thing. So 0 equals x minus 6 times x minus 6. So we only need to set one of them. So x minus 6 equals 0. Add 6. X equals 6. Which then means our intercept is 6 comma 0. Oops. Now, letter C, there's no parenthesis here, okay? But there's an x. So that means we're going to set that equal to 0. So we're going to have 5x equals 0, and x plus 3 equals 0. Well, if we divide both sides by 5, x equals 0, minus 3, x equals negative 3. So then our intercepts become negative 3 comma 0 and 0 comma 0. So those are the two x-intercepts. So if we have an x in front like this, that means we have to set that equal to 0. You'll see down here, okay, we have a 4 in front. There's no x. So we're not going to set that 4 equal to 0. Again, up here, that was 5x. So that's why we set that equal to 0. 5x equals 0. Down here is just 4. So we don't need to do anything with that. So we're going to have x minus 8 equals 0 and x minus 12 equals 0. Add 8. So x equals 8. And 12, x equals 12. And I'm not going to write them as an ordered pair or as intercepts because the directions say which values of x satisfy the equations below. X equals 8 does, and x equals 12 does. Right, if we look at B, right, we're going to set each part equal to 0. X plus 5 equals 0. And this one, 2x minus 12 equals 0. So subtract 5. X equals negative 5. Okay, that's one of our solutions. However, for 2x minus 12 equals 0, all right, we're going to add 12. 2x equals 12. But we have to divide by 2 because we have a 2 in front. Whoops, not 12, 6. So we had to do that little step because of this 2 this 2 out in front. Right, so to set each part equal to 0 and solve. So those are 2 answers. So intercept forms of quadratic, that's written as x minus p times x minus q. And we can have an a value in the front, and actually, I'm going to write that a little bit neater. So y equals a times x minus p times x minus q. And that means our intercepts, we have intercepts at p comma 0 and q comma 0. Those are the 2 x-intercepts. And the vertex is halfway, or halfway in between the 2 x-intercepts. I don't like how this looks. Okay. So we're going to graph this example here. The first thing we want to do, plot intercepts. So our intercepts are going to be positive 1 comma 0 and positive 3 comma 0. So I'm going to go and plot those. 1 comma 0. The next thing I want to do is find my axis of symmetry. Find AOS. And one way you can do that, to find the halfway point, and maybe you remember this from geometry, halfway and midpoint are the same thing. We can add these two and divide by 2. So my axis of symmetry is x equals 2. So I'm going to draw that in. Here's 2, and I'm just going to draw that in. So I know my vertex will lie on this axis of symmetry. The third thing we're going to do, plug in AOS, axis of symmetry, to find y-coordinate of the vertex. So I'm going to take 2 and plug it into both x's up here. So y equals 2 times 2 minus 1 times 2 minus 3. So we can type that in the calculator, and I'm doing that off screen real quick. Um, 2 times 2 minus 1 times 2 minus 3, and I get negative 2. So 1, 2. Here we go. So now, I know we usually would get a couple more points when we were graphing in vertex form, but a lot of times in intercept form we won't need those other points. For today, we'll just focus on getting those 3, and then it's going to be a U shape, so it should look like that. Now the vertex, the x coordinate was 2, the y-coordinate was negative 2. So 2 comma negative 2. That's our vertex, 2 comma negative 2. And we have a minimum value because it's opened upwards, so it's a minimum at y equals negative 2. Domain. Domain for quadratics is always negative infinity comma infinity. The range. We're opened upwards and we have a minimum value, so our range will be negative 2 comma infinity. And then end behavior as x approaches negative infinity and as x approaches positive infinity. Both sides are going up. So y approaches infinity, y approaches infinity. So this stuff, domain, range, and end behavior, that's still things that you are used to. The new stuff is up here. You know, getting our graph. You know, once we have the graph drawn, I know you guys are great at getting the rest done. So that's the new stuff. So let's do another one. Our intercepts. So, you know, up here the first step was plot the intercepts. Our intercepts here are negative 2 comma 0 and 4 comma 0. You know, the opposite of what you see. So negative 2 comma 0 and positive 4 comma 0. Now the second thing we're going to do is graph your axis of symmetry. So what you can go over here and count, okay, what's going to be halfway in between, and that's fine. If you counted, that's fine. But you can always go over and say, okay, negative 2 plus 4 over 2 is going to be 2 over 2, which is 1. So your axis of symmetry is x equals 1. And then the third step, take this 1 value and plug it in for both x's. So 1/2 times 1 plus 2 times 1 minus 4. So again, off screen, I'm going to calculate this. 1/2 times 1 plus 2 times 1 minus 4. And I got negative 4.5. So that means my vertex is 1 comma negative 4.5. 1, 2, 3, 4.5. It is a minimum value at y equals negative 4.5. Domain, negative infinity, comma infinity. Range, negative 4.5, comma infinity, because we have a minimum value here. So negative 4.5 is my lowest y value, and we're opened upwards. End behavior. As x approaches negative infinity, and as x approaches positive infinity, y approaches infinity, and y approaches infinity. Alright, we'll do example number 5. We'll save 6 for when I get back. So write a quadratic equation in intercept form that opens down. Okay, so opens down means a is negative and has intercepts at -3 comma 0 and 8 comma 0. So y equals negative a value. So let's do -2. X plus 3 times x minus 8. That will be okay. You could have any other negative number up and you'd be fine. Okay, so that's as far as we're going to go today. Your assignment is on the next page. If you want, we can just take a quick peek at that. It should look like this. You're graphing on the front page. This one, numbers 5 and 6, remember intercepts, x-intercepts are when y is 0. Y-intercept is when x is 0. So that will help you. So try these. I know some of them might be a little bit of a stretch. Simplifying radicals, you guys are good at that. Solving the equation, you're good at that. We'll probably have to come back to number 9 and talk about that one. But try these, especially the graphs. I want to see what you need help with, and then on Friday we'll see what you know and kind of go from there. So, all right, guys, I'll see you soon. Bye.